Okay, guys, let's do a two proportion z-test based on this scenario. Okay, so the student council of large high school wondering if junior seniors are more likely to attend prom. They sample some juniors, they sample some seniors. We want to know, is there evidence of a difference in the proportions? Okay, so again, I'm going to compare these two proportions, not a single proportion to a status quo. Okay, so I'm going to have proportion equals proportion. I'm going to do proportion J equals proportion S, because what that means is proportion J is the true population proportion of juniors who are going to the prom. And P sub S is the true population proportion of seniors going to the prom. Okay, so if the proportions are the same, then there is no difference. Okay. So if they are equal to each other, the true population proportion of juniors going to the prom is equal to the true population proportion of seniors going to the prom. There is no difference. Okay. So what we'll check down here, let's do this one a little different. Okay. If we looked at our samples, we did have more seniors. So let's do a less than. Let's do juniors less than seniors. Okay. Just do something a little different since we did a not equal the last time. Okay. But again, if we look at our conclusion, since the interval contains 0, there is not evidence of a difference. Okay, so since the interval included 0, I should fail to reject the hoe because I don't have evidence that there is a difference. There's probably no difference. Okay, so I should fail to reject the hoe. Let's get there. Okay, my alpha. This was a 95% confidence interval, so we'll do a 5% alpha. And then we'll do our plan. And again, we've got to do our plan for our juniors and our seniors. So let me try to get all this organized here. Okay, so now this is a two proportion z-test. Okay, because these are for proportions and it's two proportions. It's not one proportion equals some number. I'm comparing two proportions. So I got to do my conditions for both, for juniors and seniors. Okay, so random. I do believe it was stated. I'm just going to abbreviate this. Okay, stated. Independence. So our 10%. Pretty sure there's more than 500 juniors. And pretty sure there's more than 450 seniors at this school. It did say it was a large high school. Okay, and of course, students are all independent. Okay, and then for normal, I have to do large counts, but I got to do it twice. Now I don't have a P, you know what I mean? All I have are my two P hats. So I'm going to do my sample size for my juniors times the P hat, and that's 28, that's greater than 10. And then 50 times 1 minus 0.56, oh God, what is that? 22 is greater than or equal to 10. And I'm going to do the same thing for my seniors. So 45 times 0.64. So 29 is greater than or equal to 10. And then 45 times 1 minus 64. I think that's 16 is greater than 10. Is it 16 or 18? Okay, hold on. Yeah, he's out today. Thanks. Sorry, had to answer my phone. Okay, so my large counts works for my juniors and my seniors. Everything's greater than 10, I'm good. So again, it's the same stuff. I just got to do double duty. Okay, so let's do the do. Again, let's look at our sheet here. I'm not going to go through all this. Okay, plus there's like a combine P, combine where I got to combine my X's and my N's. I'm just going to run all this in the calculator. Okay. So when I run it in the calculator, I'm going to go over to my tests. And again, this is a 2 proportion Z test. So here we go. I did do juniors first. So juniors are going to be my 1s and seniors are going to be my 2s. So let's see. My X of my juniors was 28. Sample size was 50. For my seniors, it was 29 over 45. The symbol of my ha is less than. Okay. And again, I went less than because the sample of the juniors was less than the seniors. And I'm going to calculate. So my Z score or Z test statistic was negative 0.839. My p-value is 0.201. Okay, and then I don't need anything else. Okay. That p-value is pretty big. So when I do my conclusion, when I test my p-value against my alpha, what was my alpha? 0.05. That is definitely not true. My p-value is not less than alpha, so therefore I'm going to fail to reject the HO. I don't have evidence that fewer juniors are going. Okay, so that corresponds with my confidence interval that there isn't, I really don't have evidence of a difference, okay, because I failed to reject the HO and I don't have evidence that there is a difference, okay. 0.201 is not less than alpha 0.05, so we fail to reject the HO. Okay. I do not have evidence, the true evidence that the true population proportion of juniors going to the prom is less than seniors, or less than the proportion of seniors. Okay, so again, I didn't have evidence that there's a difference, which totally coincides with my interval because it contains 0. So there's probably no difference, okay, between the proportions of juniors and seniors going to the prom. So again, conclusion's the same. I'm going to cheat a little bit on my do it in the calculator. Conditions are the same. I just got to do them for both juniors and seniors. The ho and the ha is where it's different, okay? And again, I'm going to compare each proportion to each other as opposed to proportion of juniors to some number and proportion of seniors to some number, okay? All right, so I hope this was helpful. There's one more coming.